Well, hello, advanced algebra students. We're here today to do our next lesson, which is about practicing graphs of both exponential and logarithmic functions. In order to successfully understand this lesson, in front of you, you should have something to write with, ideally a pencil, some blank paper, and a graphing calculator. So those are the things that would be useful. If you don't have those things, pause the video and then come back in a minute. Now that you have those things, we would like you to take a look at these 4 warm-up questions to get yourself in math mode. And so you can see here that we would like you to look at each pair of equations and tell us what kind of transformation is represented in each. Please pause the video to give yourself time and then come back in a minute. Okay, so hopefully you remembered the key things are to look for things that are different between the parent function and the offspring function, so to speak. So you have in this first example a reflection and a slide. In the second reflection, there are 3 different things to account for. In the third, there's just this 3. And the difference in the fourth, if you look at those 2 equations, the 2 differences are the -2 and the 4. So take a look here and compare your answers to mine. In number 1, you should have set a reflection over the x-axis and a slide up of 5. In question 2, that 1/2 is going to squish the graph in a vertical direction. So you might have set a squish, or you might have set a scale factor change of a 1/2 or something like that. And then you slide to the left 2 and down 5. In question 3, remember that things with the x were kind of backwards of what you might anticipate. So although that might look to you like a stretch of a factor of 3, the factor is actually 1/3, or all of the x's get divided by 3 or multiplied by 1/3. All of those would be good answers. Question 4, you want to have said there's a vertical stretch by a factor of 4, and your graph is 2 units to the right. Now, the thing that is a little bit new is not so much the transformations, because we've been doing that all year, but what is kind of new in this lesson is applying them to exponential and log curves. So I have a summary page here, and depending on how fastidious you want to be about your note taking, you could pause this and write this down, but you do have things like this in your notes from previous units. You know that when you have things that are with the x and are adding and subtracting, that's sliding left and right. Adding and subtracting next to the function but not with the x, like separate from the x, is sliding up and down. You know about reflections and stretches and shrinks. So this is just a summary of those rules, but it's going to be applied now to exponential functions. So the examples that are over here are indeed all using the parent function y equals 4 to the x, and then they have explanations in words of what each of those would do. So take notes on that if you wish, and if you don't, that's okay. These notes are for you to help understand things, so your choice. Question 5 that I have here is to describe a transformation, and so this function f is the parent function, and then over here we have the variation on that. And I know that in my class we had talked about how 1/2 to the x is the same as 2 to the negative x, and that might be useful to you just in terms of thinking, and if it's not, then you don't have to utilize that. But something that you might want to do to just think about the different exponents here would be to utilize your calculator. So I'm going to think about points that are on the parent function. So I'm going to think about, okay, what if I just made a little input-output chart here and just said, let x equal 1. So 1/2 to the 1, or 2 to the -1 is a 1/2. And I noticed then that that's not the most convenient point to try to graph. So I'm going to try to look at some other points that might be easier for me to find. I know when I take something that isn't 0 to the 0 power, I get 1. I'm going to try -1. Now, usually negatives are maybe harder than positives to think about, but here I have an opposite sign. So I have 2 to the opposite of -1, which would just be 2. You also could think of putting that in the original and saying I have 1/2 to the -1, which flips it over and makes it 2. And so that means that -2 is also going to be kind of convenient. That's going to be 4. So I could think about these points, and I'm just going to plot these in yellow, actually, because this is not my final answer. This is the graph of f. So I've got 0, 1, 1, 1/2, -1, 2, -2, 4. I'd also have -3, 8 if you want to just know that, okay? So this is my graph of f. Right? And then the graph of g is going to be the same shape. It's also going to be exponential decay, but this has moved it, well, do you know? It's moved it down 4. So something that I didn't talk about a second ago is how the original graph f has a horizontal asymptote at the x-axis at 0. And so the horizontal asymptote for my new graph is going to be down 4 units from that. Make sure I draw it in the right spot. So there-ish. It's kind of a fat line, so thanks for your patience with that. And then I could take each of these yellow dots and move them down 4. 1, 2, 3, 4. And just count. All right, so now I know where to draw my curve. It's down 4. So the slides that we've learned before totally still work. Same thing. What might be a little new to you is coming up with these points, but I would encourage you to put equations in your y equals menu on your graphing calculator, and then use table to find some nice points that are easy enough to graph. Okay, so here's a picture that I already made. Okay, number 6. All right, for number 6, we're looking at the parent function y equals e to the x. I would suggest that you put that on your calculator or make a chart. And so some key points would be if I put in 1, I'm going to get e to the 1, which is about 2.7. If I put in 0, I'm going to get e to the 0, which is exactly 1. So if I were to even just plot those 2 points and know that this is going to be exponential growth because the exponent here is a positive x, not a negative x, I will already from just that much know that my shape should look like that. But again, if you're nervous about that, utilize your technology. Put this in your y1 and look at table. So that graph is my parent function, and now look at this. So I know that this graph that I'm about to draw is going to be the same as the green graph, except 3 to the left and up 2. So I'm going to go 1, 2, 3 to the left and up 2. Take this point and go 1, 2, 3 to the left. Up 2 is a little bit hard. You're kind of in between lines. I think you can just think about that. And then it does help to know that this line here was an asymptote. If I move that line 3 to the left, well, it's still the same line. Sliding a horizontal line horizontally doesn't change the line at all, but up 2 sure does. So my new asymptote would be up there, and then my curve would look like so-ish. I'm not a very good drawer. Okay, so you can see I had the yellow dots that were on the e to the x, and then here's the new graph. All right, so the next part says, describe the transformation of f represented by g. I'd like you to pause the video, write down what you think happens. So if this is the parent function, how does g change relative to f? And the same thing here. This is the parent function. What change happened? So I'd like you to pause the video so you can still see the questions, write down what you think your answers are, and come right back. Okay, so hopefully this is what you also have. So in question 6, the 3 slides you to the right, and the wand will slide you up, and I have a picture here of what that graph would look like. The yellow dots on my picture are of the parent are from the parent function. Though I just noticed I have a little mistake here, I think. Do I? 1, 2, 3. No, maybe I'm okay. So those yellow dots are from the parent function, and then the colored in graph, the solid graph, is g of x, and then the same thing is true on my second graph. I know you didn't have to graph, I'm just showing you. Okay, this slide, I don't know if it's absolutely necessary, but what the point of the slide is that all of the transformation types that we have previously studied can also be applied to a log graph. So over here they have the parent graph that they're using is the base 10 log function, and they've shown here a variety of different examples and the transformations that occur with each example, and just kind of showing you in general that all of this that we've done before, that still is a thing. Okay, so that's not really new, it's just pointing out that the application can still occur. All right, so in this question, this one's a little bit dicey because the base of the log is a fraction, but we can handle it, okay? So it says describe the transformation, starting with F, ending up with G, so that's going to be words, and then coming up with the graph is the part that I think is actually a little bit complex, perhaps. Okay, so looking at this as the parent function, and then looking over here, I see two things that are different. There's a 2 and there's this +4. So those two things need to be accounted for. The 2 is going to be a stretch. So this is going to be a vertical stretch because it's apart from the x by a factor of 2. So all of the y's are going to get multiplied by 2. The part that is the 4 is going to be a slide. Since it's with the x, it works backwards of what you might, just kind of guess. So x plus 4 is going to move 4 to the left. And that's a slide. Okay, so that's what's going to happen at the end. Okay, but first we need to find our parent function. So our parent function is y equals log with a base of a half of x. If we write this in exponential form, the base is a half, a log is an exponent, so this is my exponent, and that's x. Typically, we have in math, like when we're in algebra class, back in the day, algebra 1, we would always make an XY chart and we'd fill in values for x. Here, it's going to be easier for us to fill in values for y. And we actually did part of this question, this part right here, in the warm-up a little bit. Okay, something kind of like it. So I'm going to put in some positive and some negative numbers, and we're going to see how that goes. So put in +1 for y, and you have 1/2 to the y, or 1/2 to the 1, sorry, tongue-tied, and that's a half. That's kind of not convenient in terms of plotting. 1/2 to the 0 is 1. That is convenient. Great. Then I have 1/2 to the -1. Well, a negative exponent switches top and bottom, so then I'd have just 2 to the +1, which is 2. That's helpful. And then my last one is going to be 1/2 to the -2, which would be 2 over 1 to the +2, which is 4. So we're going to plot those points. So here's my graph, and then I'm going to apply the transformation. So we said we're going to stretch by a factor of 2 and move 4 to the left. So for instance, this point is at 0, and if I multiply by 2, it's still at 0. But 4 to the left, we'll move it here. This point was at 1 for the y, and so if I multiply it by 2, it will be at 2, and then I go 1, 2, 3, 4. Oops. I forgot I was in between. 1, 2, 3, 4. Here you go. I'll be over here. And then this point, which is at 2, -1, would go down, -1 times 2 is -2, and then move 4 over. And I have this point, which is at -2 for the y. So that's going to go to -4 for the y, because -2 times 2 is what I'm doing, right? A factor of 2, and then multiplying by that 2. And then I go 4 to the left. And when I connect those dots, this is what I have. Now you notice that I tried to help my poor drawing ability by drawing in my vertical asymptotes. So just as exponential growth and decay back here had horizontal asymptotes, log curve, because it is the inverse, has a vertical asymptote. I don't know how much your teacher has talked about that yet, but that is the case, okay? So they're reflections of each other. All right, I have a problem for you to try. It says describe the transformation and then graph. If you don't have graph paper, you could just list the ordered pairs or just create a little grid for yourself. Hopefully this is what you have for yourself. So you should rewrite the equation of f of x in exponential form. So that would be 2 to the y equals x, or x equals 2 to the y. You should plug in values for y that allow you to find x's. I did all of that in green ink, and then on my graph you see in green ink with highlighted blue dots the graph of that. And if you look back at g of x, the -3 does two things. It flips the graph over the x-axis and also stretches it. In other words, all of the y coordinates on my blue ordered pairs are multiplied by -3. And that is what generates the flip, is the negative aspect. All right, the rest of this video is going to be a little strange perhaps, but the rest of this video has a lot of practice problems. I know a lot of you appreciate being able to practice things before you have to take an assessment, and so I want to make sure that you have access to the kind of practice we would do if we were meeting face-to-face. So what I am going to show for the rest of the video are a series of practice problems, and every time a new set of problems, couple problems at a time, comes up on the screen, you can pause your video and work the problem, and then you can unpause the video, and in a little bit I will show an answer to that. I'm not going to talk through this. I'm just going to show, question and answer, question and answer. And so if you have questions, definitely communicate with your teacher through Schoology and just say, hey, I have a question about this problem, and your teacher will be happy to answer. So do as many of these as you want. If you feel comfortable, you don't have to necessarily do them, but make sure that you answer the question that was posted underneath this video so that your teacher knows you attended class. You have some problems to do, just like you would if we were face-to-face. So in my class, my assignments are on big ideas, so we should do big ideas assignment 6.4. And if your teacher does not use the online big ideas, then make sure that you look and see what information is posted for you about homework. Okay, here's a pair of questions. You could try to graph both of these, answer about domain and range and asymptote. And like I said, I'm going to stop talking and just let you pause and look at answers as you see fit. Feel free to fast forward also.